All right, so we know the mass of our object is 7 kilograms. We know its velocity before the collision is 12 meters per second, and it's to the right. Okay, we good so far. Yeah. So once they separate, or once they explode, or whatever, once they separate, we have the two different objects. So the mass of the first, we were told, is 5. The velocity of the first post-collision is going to be what?
15.
Yeah, negative 15, because it's going south. Okay, so we can think of it, or draw the little arrow, but it is going to be going south, so it needs to be negative. Mass of the second object we know is 2 kilograms. V sub 2 prime, do we know that? No, we don't. And in order to get to that, we need to solve for V sub 2 x prime and V sub 2 y prime. Okay, those are going to be the components that we have to solve for, since we know that this is going at an angle. Okay, if this was just going to be going straight north or straight south, we wouldn't have to bother with components. But from our drawing, from our image we were shown, we know that it's going at an angle, which means we need to do components. Okay, so now we can just start working in our x and our y for momentum. So we can start solving our equations. Here, since we only have one object at the beginning, it's a simple process. Okay, so for our x, we'll take our mass times our x velocity, which is 12. Good. And all that's going to be it for the left side. Okay, you could think of it as a 5 kilogram object going 12 plus a 2 kilogram object going 12 meters per second. You could do that if you want. It makes no difference. Okay, so then our mass of this after the collision is 5. Does our first
equation use this?
We're still using m1 v1 plus m2 v2. Except we only have one object to begin with. So we only use one of those. Okay, and that'll all equal m1 v1 prime plus m2 v2 prime. Still the same equation. We're just able to take it out if we don't have two objects. Okay, so this is m1. What's our v1 prime in the x direction?
0. Wait. No, an x.
In the x direction, it's 0. Exactly. In the x direction, it's 0. When we move on to the y, then we'll get to plug in our 15. Okay? So then our 2 kilogram object, we're going to be solving for v sub 2x prime. Okay, right? Because this was 0, we're done with that. So now we'll take our 84 divided by 2, and that means our v sub 2x prime is going to be 42 meters per second. And which direction would that be going?
The right.
To the right, because it came out as a positive. Okay, why don't you go ahead and solve for y by yourself? Because our initial velocity of our whole object is only in the x direction. So it doesn't have any y components to it. So when we're solving for that for our y, that means it doesn't basically have any vertical velocity in the beginning, and it only has horizontal. Okay, so that's where the 0 comes from. Came out positive, so it should be going up. This one came out positive, so it should be going to the right. Okay, and if we look back at the picture that we were shown, okay, about the image of these two objects, was our second object going up and to the right? Do you remember?
Yep.
Yes, it was. So that's correct. So now let's go ahead and take these two components. We'll build a new triangle and solve for our hypotenuse or our resultant. Good. Meters per second at 41.8, so I'll round to 42 degrees. Perfect, north of east. If we take a look back at our original problem here, this makes sense. Our answer makes sense, which is good. And it's what we were supposed to get. Let's try an inelastic collision. Remind me what an inelastic collision means. Yep, they collide and they stay together as one unit. So this makes our problems even easier because we only have one velocity after the collision we have to worry about. Okay, so this is a pretty straightforward inelastic collision problem. Go ahead and get it written down if you want to. I'll give you a few minutes and then we'll start our math. We still have to break this one down into x and y. So after we've got our whole list down here, we know our components. This is our inelastic collision equation. We're going to break it down into x and y. The good news about this problem is that we didn't have to break down any vectors initially from components, right? Nothing started at an angle, which means we didn't have to break anything down. So we'll go ahead and start with our mass 1 times our velocity 1. Is this velocity horizontal or vertical? Horizontal, which means it gets to be plugged in here. Okay, the second object was 600 kilograms. Is its velocity horizontal or vertical? Vertical, which means we get a 0 there. Okay. Mass 1 plus mass 2 goes here, which will be, yes, 1,500, and we're going to solve for v sub x prime. All right, so we get our v sub x prime to equal 7.2. Okay. All right, and in what direction should that go, Elizabeth? Yep, right or east, however you want to say it. Good. Because it's positive, and we chose east to be the positive direction. For y now. Momentum in the y direction. Does our initial first object velocity have a y component? Nope, so that's going to be a 0. Now we get to plug in our 24, and since it's going north, it gets to be positive. Okay, we're going to combine our two masses here right off the bat, and we'll say 1,500 times v sub y prime. .666. And since that's positive, we know it's going in what direction? Up. Perfect. All right, so we have our two components here, v sub x prime and v sub y prime. Now we can build our new triangle, add these components tail to tip, and build our new resultant vector. Okay, so 12 meters per second at 53 degrees north of east. Let me just clarify that it makes absolutely no difference if we draw our vectors tail to tip this way, or if we would go, let's say we go north first and then east. We would go this way and then this way. It would make absolutely no difference. We'd still solve for v prime. We'd still solve for this angle. But in that case, the angle would be east of north instead of north of east. Okay, it makes no difference in which order you draw those vectors tail to tip, as long as they're done correctly tail to tip.